This is mass spec. Okay.
Let me get my notebook so I can take some of this one. If I see that. Yeah.
Okay, so your graph kind of looks like this. You have abundance versus mz, which is mass to charge ratio. And so what happens is you have that molecule, so it looks like this, C, 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 and you got H's coming off, H right there, and then you have an OH?
Oh, yeah.
Yeah, OH. Okay, so that's your molecule. If you calculate the weight of that, the whole molecule together, that's going to be your molecular ion right there, M plus. And it should be, let's see, what is it about? It looks like it's 58-ish. It's about 58. So what a mass spec, is they take this compound and they put it through like a little machine that basically tears it into parts, just rips it into little parts, and then gives you the weight of those parts, or the mass of each of those parts, and their relative abundance. So the heaviest guy on here, the furthest to the right, that's always going to be the molecular weight of the entire molecule. And then these little peaks that you have, those are just going to be fragments. So say it got cut right there. Now this piece is going to weigh less than the whole molecule, so it's going to be probably right there. And so it might be the tallest. I'd probably guess that this would be the tallest. So we lose another chunk, puts us to right there. It could lose this carbon and just be an OH. And so each of these peaks just represent a fragment of that molecule. Does that make sense? So here's your molecule.
Okay.
And what they do is they say they don't know what it is. You put your molecule into this machine and it tells you how much it'll weigh. So you could determine the molar mass, the weight of this molecule. And then it also tells you the fragments that most likely...
Those two?
Yeah. Yep. So let's see what your question asks. It says, mass spec is shown. Draw the structure of the positively charged fragment that produces the highest peak in the spectra. Okay. So this right there, that little bitty peak, right at 58, see that little guy?
Yeah.
That's this whole molecule.
Oh, okay.
And now it wants you to draw what produces that biggest peak right there.
Okay.
So you have to look at how much mass you lost. So you went from 50, let's see, that's 2, 4, 6, 8. No. Yeah, 8. So that's 59. So you went from 59 to 42 for 45. So your peak right here, let me draw that. So this is 59.
Okay.
And this is 45. So you lost a piece that weighed 59 minus 45, or that weighed 13, no, 14. Is that right?
14.
Is that 45, 2, 4, 5, yeah.
So this one is 45?
Yep.
Okay. Yeah, when I look at those little letters, lines.
Yeah, it's kind of hard to see.
So that's 41, 42, 43, 44, 45, right?
Yep.
Okay. Makes sense.
So we lost 14 units of mass going from here to here. So now you just have to look back at your molecule and think what piece could we have lost that weighs 14? So carbon we know weighs 12, and these are all hydrogens, hydrogen, hydrogen. So if that's 12, then each of these is 1, because hydrogens weigh 1.
Right.
Then that's 12, 13, 14, 15. That's weird, because I think you just lost that. I think that should be 15. 49, 59. Let's see if you got those right. Yeah, that's 59, and that's 42, 45, 45. And 59, 49, 48, 47, 46, 45, that's 14. 12, 13, 14. Let me think. 34, 40, 43, 44, 45, yeah, that's right. So what we would have left would be 12, 24, plus 16 is 34, 40, 41, 42, 43, 44, 45. Yeah, so 45, 46, 47, 48, 58, 60. Yeah, so this should be at 60.
60? Oh.
Yeah. And so that lost a piece of 15. So what happens is this tallest peak right here was made because this this chunk fell off.
Right.
And so you went from the mass of the whole thing was 60, and now the mass of just this is 45.
Oh, okay. I see.
So now it just wants you to draw that and put the positive charge, because this atom, because it lost those electrons, now has a positive charge on it.
Oh, okay.
So it's just asking you to draw this chunk.
Oh, okay. That makes sense.
So what do you think, say we have another peak right here at, what would it be, 45, 30, so that's at 30. What would be the structure of this fragment with a weight of 30?
It's 30 in this chart?
Yep. So this one has 45, so it lost something and became 30.
Right.
So what do you think it lost? It lost 15, because the difference between here is 15.
Let's see, 12, 13, 14, no, wait, 12, 13, 14, 15. I think.
Yeah.
Yeah, that's it.
So what piece fell off?
That,
This one?
This one, yeah.
Yeah. So if it lost this guy, now that'll weigh 30. And so that's probably what gave this peak at 30.
Okay.
So you just kind of have to use math to go, okay, you went from 59 to 45, so you lost something that weighs 15. And so if you just add that up, this CH3 group weighs 15. So that just fell off.
Oh, okay, I got you. I see. So you're talking about about this part, right?
Yep.
They're talking about that one, and then the big line is to how much you lost, right?
Yep, exactly.
Oh, I see.
That line is this whole molecule.
Okay.
This line is what's left when you lose 15 units of mass.
Okay, I see. Okay. Yep. So the answer is this one. This.
Yep, perfect. It would just lose this little chunk right here. So it would be that C, those three H's, this C, that H, that O, and that H. And the rest would have fallen off.
Okay. So. Oops. Wake up. So then how do I, when I draw this down, how do I put the plus in there?
It'll let you if you click on the diagram.
Uh-huh.
So loading editors. So now what you'll do is you'll just click the carbons because you'll have 2 carbons. So you'll click on the C.
C. Here.
Okay, and then put another C over there.
Oop.
Oh, you need to click on the C box down here.
Oh,
Yeah, now it'll let you.
okay.
So C and the C over here. Yep. And then you can change your C to an H or an O. Let's do O first.
Okay.
And then the O will go right above the C, yep.
Here.
Yep. And then we could change it to an H. And add 3 H's around that C, an H, and an H. Perfect.
Okay.
Perfect. And then just click on the line and connect them all.
Oops. Oh, dang it.
Yeah, it's kind of tricky.
Can you see the one there?
Yeah, that's good. And then the positive, yep, just that guy. And you'll just click the carbon.
Here?
Yep. And then type up plus.
Right?
Yep. Yep,
Okay.
that's it.
Hmm.
So make sure to draw the positive charge on the fragment on the right atom. Yep.
Okay. There it goes.
Nice. Perfect.